Hello and welcome to this detailed explanation of the Lsig settings of ABB PR121P protection trip unit. We will be walking through the presentation section by section to understand the features and functions of this crucial device. The first section introduces the SACE PR121P protection trip unit designed for the ABB SACE Emax series of air circuit breakers. This unit is the brain of the breaker, responsible for detecting faults and initiating the trip to protect your electrical system. The PR121P is a complete trip unit that offers full protection functions with adjustable current settings or thresholds and operating delays or trip times. It's suitable for a wide range of AC applications, including industrial, commercial, and utility settings. A key feature is the multifunction LED indicators, which provide a clear status of the respective faults. The unit also allows for external device connectivity for remote signaling, remote monitoring, and remote supervision display. Let's move on to protection functions of PR121P. The presentation shows the front panel of the PR121P and introduces its four main protection functions, which are often abbreviated as LSIC, where L stands for long time, which is for overload protection. S stands for short time, providing protection against low-level short circuits. I is for instantaneous for high-level short circuit protection. And finally, G stands for ground fault protection. Let's dive deeper into the first function, a long time or overload protection. Its purpose is to prevent overheating from sustained overloads while still allowing for normal short bursts of extra current. The working principle is based on an inverse long time delay trip curve where the trip time is inversely proportional to the square of the current. T is equal to K by I square. In simple terms, the higher the overload current, the faster the trip, which stimulates the heating effect in equipment. The settings for the L functions include 25 current thresholds I1 with a minimum of 0.4 times IN and a maximum of IN, where IN is the rated current. It also has 8 trip time delay settings, T1 at I is equal to 3 times of I1, where I1 is the current thresholds. Here's an example with a rated current I1 of 2000 ampere. If the trip threshold I1 is set to 0.8 times of IN, which is 1600 ampere, and the trip time delay is 12 seconds at 3 times of I1, that is 4800 ampere. This means any load less than 1600 ampere will not cause a trip. If the current reaches 4800 ampere, it will trip after 12 seconds. Following the inverse time formula, if the current is at 1600 ampere, the trip would occur after 108 seconds. At even higher currents, the trip time will be faster. Next is the S short time function, which is for low level short circuit protection. Its purpose is to clear moderate short circuits while ensuring coordination with downstream breakers. The unit detects currents above the short time pickup and trips after a preset short delay. This delay allows the downstream devices to clear the fault fast. The S function has 15 current thresholds I2 ranging from 1 times IN to 10 times IN. It offers two curve types, definite time T is equal to K, where the trip time is fixed, and inverse time T is equal to K by I square, where higher currents results in a faster trip. The functions also have a trip time delay settings T2 at I is greater than equal to I2 for the curve type T is equal to K, and at I is equal to 10 times of In for the curve type T is equal to K by I square, and can be turned off or disabled. Now coming to the short time examples. This section provides two examples for the short time function with an In of 2000 ampere. In the first example, with a definite time curve, if the trip threshold is set to I2 is equal to 4000 ampere and the trip time delay is 0.1 seconds, any fault current above 4000 ampere will cause a trip after 0.1 seconds. In the second example, using an inverse time curve, if the trip threshold is set to I2 is equal to 4000 ampere and the trip time is 0.1 seconds at 10 times of In, that is 20,000 ampere. Based on the inverse time formula, a fault at 4000 ampere would take 2.5 seconds to trip, allowing downstream devices to clear the fault fast. Let's move on to the third function. The third function is instantaneous, which provides high level short circuit protection. Its purpose is to protect equipment from severe fault currents by tripping without delay. It works by monitoring for current exceeding the instantaneous threshold and trips the breaker almost immediately. The settings include 15 current thresholds I3 from 1.5 times In to 15 times In. The functions can also be turned off or disabled by dip switches. Let's look an example with an In of 2000 ampere. A trip threshold of I3 is equal to 4 times of In, that is 8000 ampere, will result in a trip within 20 to 50 milliseconds for any fault current above that value. Finally, we have the G, ground fault protection. The purpose of these functions is to prevent hazards from leakage currents to the ground, which reduces fire and shock risks. It works by sensing an imbalance in the vector sum of the phase currents to indicate a ground fault and trips after a set delay. There are 7 current thresholds I4 for this function, ranging from 0.2 times In to 1 times In. It has two curve types, definite time T is equal to K and inverse time T is equal to K by I square. It has 4 trip time delay settings T4 and can be disabled by dip switches. In an example with a definite time curve and an In of 2000 ampere, a trip threshold of 400 ampere and a trip time delay of 0.2 seconds at trip threshold means any leakage current above 400 ampere will result in a trip after 0.2 seconds. With an inverse time curve and the same settings, a 400 ampere leakage will still trip in 0.2 seconds, but a higher leakage of 800 ampere would trip faster in 0.075 seconds. Now let's have a look on the time current graph. It shows the relationship between the magnitude of a fault current and the time it takes to trip for a protective devices like a circuit breaker. Here the horizontal axis represents the current in amperes and the vertical axis represents the time in seconds. This is also the same time current graph, but here the two graphs are separated by different curve types. Where in one graph I square t is on and in other graph I square t is off. Let's move on to tolerance. This section explains the concept of tolerance. Tolerance is the acceptable variations from a set value due to minor manufacturing imperfections and environmental factors. For trip thresholds, this means a current setting is not a sharp line. For example, the S function has a plus minus 10% tolerance. So a 10,000 ampere setting will trip somewhere between 9,000 ampere and 11,000 ampere. Similarly, trip times are not exact. For the G function, a plus minus 20% tolerance on a 0.2 seconds setting means the actual trip time could be between 0.16 and 0.24 seconds. Let's coming to the LED indicators. The final section covers the LED indicators. The unit has up to 4 LEDs to signal its status. These LEDs can indicate that a protection function is dimming towards a trip. When a trip has occurred, which is activated by pressing the info or test button. This can also indicate a failure has been detected in a current sensor or opening solenoid, or also indicate when a wrong rating plug is being used. To sum it up, that concludes our detailed look at the SACE PR121P protection trip unit. We have covered the Lsig protection functions, their working principles, settings, and the important concept of tolerance. If this helped you understand these Lsig protection functions, hit that like button and subscribe for more engineering tutorials. Thanks for watching.